Okay, Bismillah ar-Rahman ar-Rahim. Today, inshallah, we're going to complete our talk about the producer behavior, which we have started in the previous class. We still have some terms and concepts related to the producer behavior. One of these terms is the production function. The production function is the maximum outputs or the maximum quantity of production that the firm can produce using the different combinations of inputs. So, the quantity produced equals function of inputs. Labor, machines, raw material, and land, so on, etc. So we have outputs is function of inputs. If inputs increased or the factors of production increased, the output would increase, right? Okay. We have, as you know, that we have variable and fixed factors of production. In the short run, the output is function of the variable factors of production, like labor. So in the short run, the output can be produced or increased, could be increased by increasing of the variable factors of production. Or in the short run, some of the factors of production would be variable and some of them would be fixed. Yes, would be constant. So in the short run, the output is function of the variable factors of production. In the short run, some of the factors of production would be or are fixed. And in the long run, the output is function of the whole of factors of production. And in this case, all of the factors of production would be variable. So let's take the following exercise to understand the idea well. Suppose that we have the following information about a firm and its production using different combinations of the factors production, labor and machines. Machines, labor, the total production. Total production equals the quantity produced. Total production means the quantity produced. One. As we mentioned that in the short run, the number of machines or capital will be fixed. Suppose we have a fixed number of machines. 6. Yes, in the short run. And the number of labor is variable. We have different numbers of labor. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And suppose that these different combinations of factors of production gives us, okay, and these different factors, these different combinations give us different outputs. So suppose the first combination, which is 6 machines and 0 of labor, gives us the total production of 0 for sure. 6 machines and 1 of labor gives us 50 units, 120, 180, 220, 250, 270, 280, 280, 270, 250. The question is, calculate the total or the average production of labor and the marginal production of labor, as well as draw and derive the function. Draw and derive the marginal, the total production, the average production, and the marginal production functions. Okay? Okay. 2. So the question is, calculate the average production of labor, the marginal production of labor. ABL, average production of labor, and the marginal production of labor. APL equals the total production of labor over the number of labor. TPL over L, or total production over the labor, the number of labor. And the marginal production of labor equals the change in total production over the change of labor, or delta TPL over T over L, or delta L, right? So in this case, APL equals total production of labor over L, number of labor, yes. Or we can write it as below: the total production, the quantity produced, over the quantity of labor. This is the total production over the quantity of labor, right? For MBL, the marginal production of labor, MBL, delta TPA, delta total production over delta L, or delta Q over delta quantity of labor. This is the number of labor, right? So let's start. In the first case, there is TPL over L at 0, and then 50 over 1, 50, 60, 60, 55, 50, 45, 40, 55. How much? 35, 35. سناخد عشان نضيعش الوقت بس. 45, 40, 35, and then 30, yes. 25. right? Okay, what about MPL? MPL in this case, the first case, there's no change. And then TPL, delta TPL over delta L, or delta TP over delta L. 50 minus 0 over 1 minus 0. 50 over 1 equals 50. So in the first case, 50 minus 0 over 1 minus 0, 50 over 1 equals 50. So for the first case, it would be 50, and then 60 or 120 minus 50 over 2 minus 1, 70. 60, and then 40, 30, 20, how much? 10, 0, minus 10, minus 20. Sorry, minus 20, yes. So the question is, draw the total production function or curve and APL and MPL, and explain the relationship between these curves or functions. Okay? So let's derive these curves and analyze and do the analysis, or analyze the relationship between these factors or these variables. This is the total production curve. MPL, APL, this is the number of labor, L or QL, and this is the total production, APL and MPL. We have 3 stages. And the first stage, let's come back to the table and explain the relationship between the number of workers and the total production, well, APL and MPL. In this case, on this stage, when we have 3 stages. In the first stage, when the total production increasing by increasing or at increasing rate. In this stage, the total production increased from 0 to 50, and then from 50 to 120. So in this case, the total production increased by 50 and then by 70, and then khalas. This is the first phase or the first stage. In this case, or in this stage, the total production is increasing at increasing rate from 0 to 50 and then by 70, by 50, by 70. In this case, it's called the total production increasing by increasing rate. At this case, the marginal production of labor is increasing. Okay, as you see in this diagram or in this graph, we have 3 stages. In the first stage, from A to B, the total production of labor increasing at increasing rate. In this case, the MBL or the the MBL is increasing. MBL is increasing. So let's come back to the table. In this stage, as you see, when the total production increased by 50 and then by 70, it's called increasing at increasing rate. In this case, the marginal production of labor is increasing from 50 to 70, as you see. And APL as well as is increasing. The average production of labor is increasing as well. So let's come back to this table. As you see, in this stage, from A to B, it's called the first stage. The total production of labor is increasing at increasing rate. In this case, MBL is increasing and ABL is increasing as well. Right? Okay. After this stage, the total production of labor would increasing at decreasing rate. This is the total production of labor. It's increasing at decreasing rate. And in this case, the MBL, which is the blue line, is decreasing. And it's still positive. Yes. Let's go to this stage. In this stage, as you see, the total production of labor would increasing at decreasing rate from 180 to 220. How much is the increasing? Increased by 40 and then increased by 30. From 220 to 250, increased by 30. And then increased by 20. From 250 to 270, 200, and then by 10. And then 0. So it's called, in this case, the total production of labor, or the total production increased by decreasing rate. So as you see, we have an increasing, but it increased, or this increasing is by or at decreasing rate. What? Yes, it is still positive. What about MBL? MBL, as you see, has declined from 60 to 40 to 30 to 20 to 10 and so on to 0. So as you see in this stage, we can see that the MBL is decreasing. Yes, it's still positive, right? What about the third stage? Let's go to the table and come back to the graph or diagram. This is the third stage. In the third stage, the total production of labor is what? Decreasing from 270 to 250. So in this case, the total production of labor is decreasing. This is the third stage. In this case, the marginal production of labor is decreasing and negative. Right? When the total production of labor reaches the peak, the marginal production of labor is 0. Right? And it appears at the worker number 8. When the firm hires the worker number 8. What about the APL? The APL intersect or cross the MBL at the peak of APL at the worker number 3. Yes, how much is, in this case, how much is APL and MBL? At 60, yes. At this point, APL equals MBL, as you see, at the worker number 3, or at the peak of APL, or the highest or the largest amount of APL, right? And as you see, that the APL would not, it's never reached to the zero. It's never reached to the zero. ABL would remain positive, right? So let's just start in the isoquant curve. Let's just start with the isoquant curve. The isoquant curve is a curve illustrates the different combinations of the factors of production that gives the producer the same output or the same production. Let's just start with the following exercise to explain the idea of isoquant curve. Isoquant curve, which means منحنى الناتج المتساوي. Iso means equal or equals. Suppose that we have the following combinations of the factors of production and the quant produced. The combination or bundle the labor or QL. M means machines or quantum machines, and the quant produced, Q, or total production. And then let's calculate the marginal rate transportation or the technical substitution, MRTS. Bundle A, B, C, D, E. Bundle A, B, C, D, E. Labor 1, 3, 5, 7, 9, 16, 8, 4, 2, 1. And suppose that these different combinations of the factors of production give the consumer the same outputs or the same production by 1,000 units. So let's derive or draw the isoquant curve. As you see in this table that we have different combinations or different bundles of the factors production that gives the producer the same outputs. Combination A means that we use 1 labor and 16 machines that gives the consumer 1,000 units of the production, increasing the labor 3 units of labor, 3 workers with 8 machines gives the same total production. So let's draw the isoquant curve. Quantity of machine and the quantity of labor. When we say QL means quantity of labor, or L, quantity of machines, M. So quantity of machines, when we draw the isoquant curve, we can see it like this. It's quite similar to the indifference curve, which was related to the consumer, right? This is the isoquant curve. Q, suppose it equals 1,000 units, and the quantity of labor 1, 3, how much? 5, 7, and then 9. The first quantity of machines is 16. Eight, yes. And then 4, 4, 2, 1. This is point A, or combination A, B, C, D, E. So as you see, this is the isoquant curve, which is a graph, illustrates what? The different combinations of the factors, production, machines, and labor that gives or give the same outputs. What about the scarcity or the opportunity cost? What about the sacrifice? تضحية. When the firm increased its usage of, or the factors production use and the production process from 1 to 3 by 2 units, what about the sacrifice? What about the تضحية? In this case, the sacrifice is decreasing. We increased our production, or the factors production, by 2 units of labor. We use less, or we sacrifice with less machines. So in this case, it's called the marginal rate of technical substitution. The marginal rate of technical substitution means, or equals, delta QM over delta QL. Marginal rate of technical substitution. الإحلال، استبدال مكان محل عمال. So it's called MRTS. MRTS is the slope of the isoquant curve. It's the slope of the isoquant curve. الميل تبعه. So the slope equals delta Q M over delta QL, or QM2 minus QM1 over QL2 minus QL1. So let's calculate the MRTS in this example, or this exercise. In the first case, there's no change and the quantity, or there is no substitution. And the second case, delta QM over delta QL, 8 minus 16 over 3 minus 1 equals minus, the first case, 8 minus 16 over 1 or 3 minus 1 equals how much? Minus 8 over 2 minus 4. So the first case equals minus 4. And then 4 minus 8 over 5 minus 2 minus 2. Right? And then minus 1 minus half. This is the marginal rate of technical substitution between labor and machines. Right? So let's come back to the slope here. And then we will study the characteristics of the isoquant curve. What about the slope? At point A, the slope is, or before A here, it's a vertical line, right? And then what would happen to the slope? The slope is decreasing, or the MRTS is decreasing. At the horizontal line, or by the end of this curve, it would be horizontal line. So the slope would be 0. And the start, or the beginning of the left side of the indifference curve, it would be close to the vertical line. So it would be infinity. The slope would be infinity, right? Right. What about the characteristics of, or let's calculate the slope. So the slope, the slope of the iso-quant curve equals, the first one is delta qm over delta ql. Slope delta qm over delta ql. This is the first formula. And then what about the marginal production of labor? MPL equals delta TPL over delta QL, or delta Q over delta QL, right? طيب ال MPM equals what? Delta TP, total production over delta quantity of machines, equals delta Q over delta M or delta QM, right? If we divided delta MPL over MPM, we will get the same result of the slope of MRTS, or the slope of the iso-quant curve. So MPL over MPM equals delta Q over delta QL divided by MPM delta Q over delta QM. So MPL equals MPM, over MPM equals delta Q over delta QL times delta QM over delta Q. So MPL over MPM equals delta QM over delta QL, which is, or equals the slope of the iso-quant curve, or equals MRTS. Let's go to the characteristics of the iso-quant curve. The iso-quant curve. امسحها. Okay. The characteristics of the iso-quant curve. As we mentioned that the iso-quant curve is quite similar to the indifference curve, but it's related to the producer. So what are the main characteristics of the iso-quant curve when we say that it's similar to the indifference curve? Yes, it has a negative slope. Yes. So as you see that the indifference curve, or the iso-quant curve is a negative slope, and it yes, descend from up to bottom on the right hand side. صح? Number 2. What else? Yes. Yes, excellent. Number 2, that the iso-quant curves would not or are never intersect or interact with each other. So this is a quantum machines, quantum labor. Suppose that we have 2 iso-quant curves, and we have A, B, C, D, E. As we mentioned that each combination lies along or on the same iso-quant curve gives the producer the same amount of production, or the same quantum production. So in this case, A gives the same production of C and E along the quantity 1, or the iso-quant curve 1, and B equals C equals D along the iso 2. So mathematically, if A equals C equals E, B equals C equals D, in this case, A must equal B, E must equal D. But economically, it's not, because A gives larger production than B, and D gives larger production than E. So it would not, there is no logical, it's illogical. Yes, to be intersect. So the intersection or interaction between the isoquant curves is illogical, right? Right. So this is economically, mathematically right, but in economically, it's not, or illogical. Logical. What else? Yes.
The rightward shifting of the isoquant curve means more productivity.
Excellent, excellent. The rightward shifting of the isoquant curve means we have more production. ISO 1, Q1, Q2, Q3, it's called the map, right? What about the opportunity cost or the sacrifice? It's decreasing, yes. And what about, is it, as you see, is it convex or concave to the origin point? If we look to the, concave. Yes, it's concave. It's, yes, in a muhaddab, toward or on the origin point, right? Which illustrates what? Illustrates the law of diminishing what? The opportunity cost, or MRTS. تعكس تناقص تكلفة الفرصة الضائعة. Yes. So let's go to another topic, which is the ISO cost line. ISO cost line. As we have studied in the consumer behavior, as you know that we have studied the budget line. The budget line, which illustrates the ability for the consumer to purchase different bundles of X and Y. In this case, for the producer, when he wants to produce different bundles of X and Y, he wants to purchase labor and machines, or different combinations of labor, of the factors of production, labor and machines. So he needs money to purchase. This money is called the ISO cost, or the cost. We call it as cost. So what is the ISO cost line, or what is the ISO cost? The ISO cost means the different combinations of the different factors of production that gives or that cost the same amount. So if he used 2 labor and 4 machines with, or suppose it costs him $1,000, it equals the same combination of 1 worker and 5 machines. So the ISO cost line is a graph or a curve line, illustrates the different combinations of the factors production that cost the same amount, right? Suppose that the company has, or the firm has, a $1,000 available to buy different goods, or sorry, to buy the different factors of production. So suppose a firm has a $1,000 available to buy, or to be spent on 2 factors of production. labor and machines. And suppose that the price of labor equals 10. Price of labor equals $10 per unit or per worker a day, and the price of machines equals $20 per machine. The question is, derive the ISO cost line, and the ISO cost line formula. Number one, derive and draw the ISO cost line and the ISO cost line formula. This is the first question. As you know that the deriving of the budget line was QY equals I over PY. Income over the prices of Y, and the Q of X I over PX. The same idea, the same logic for the producer behavior to derive the ISO cost line. To derive the ISO cost line, we have to calculate a quantity of labor that the firm can purchase if it purchases only labor, and quantum machine equals how much can the company purchase of machines if it used only machines in the production process, right? So QM equals the total cost, this amount, the available money for to purchase or to be spent on machines, total cost over the price of machines. How much can the firm purchase of machines when it spends only this amount on or to purchase only machines? Equals 1,000 over price of machines. Price of machines equals 20. Equals. So if the company wants, or the firm wants to purchase or to buy only machines, it can purchase 50 machines and 0 of labor. What about QL? QL, total cost over the price of labor, equals how much? 1,000 over 20 over price of L10 equals 100. So in this case, if the firm wants to buy, it can buy 100 labor without machines or 50 machines without labor. So this is the ISO cost line. QM, QL. QM is how much? 50? $100. So suppose the firm decided to buy 70 labor and maybe 30. How much can it buy of machine? It buys machines. We need to calculate or to derive the budget or the ISO cost line formula, right? So suppose that the firm decided to distribute this amount to buy 70 labor. How much is the optimal number of machines that the company or the firm should buy? This is the question. So to determine how much is the optimal number of machines that the firm can buy, it depends on the ISO cost line formula. To determine or to derive the ISO cost line formula, the total cost equals price of L times QL plus PM QM. Let's calculate the quantity of machines. QM PM QM equals total cost minus PL QL. Let's divide these two sides of the formula on by PM. In this case, QM equals total cost over PM minus PL over PM QL. This is the ISO cost line formula, right? It's quite similar to the budget line formula, but in this case we're talking about the factors of production, the price of factors of production, and quantity purchase of the factor of production. So in this case QM equals the total cost equal $1,000 over the price of M. Price of M equals 20 minus PL over PM 10 over 20 times QL. So QM equals 50 minus 0.5 QL. This is the ISO cost line formula. So if the company or the firm decided to buy 70 workers, how much it can buy of machines? In this case QM equals 50 minus 0.5 times 70. Yes, QM equals 50 minus 35 equals 15. So I advise or in this case, in this combination, it can buy 15 of machines, right? Okay. What about the best or the optimal or the equilibrium? The equilibrium and the consumer behavior, as you know, is or achieved when the slope of indifference curve equals the slope of the budget line, or the tangency. There is a tangency between the indifference curve and the budget line. And here, what is the situation? It's the same. When there is a tangency between, yes. So the equilibrium occurs when there is a tangency between the ISO quantity. This is the ISO quant. When it tangent the ISO cost line. What about this point? This is point E. This is the equilibrium point. What about this point? Let's do a comparison between A, E, M, or B. A and E. E is better than A because at E, suppose here we have Q equals 500 and here Q equals 700 units. At point A, he spends how much? Or the firm spends how much? $1,000 and they get how much? 700 units. At A, they spend the same amount, $1,000, and they get 500. So A is better than A, right? What about E and B? The same. What about this point? Yes, it's unreachable point, but it's desirable. It's unreachable, unattainable.
If you increase the amount you pay, you can reach.
Excellent, excellent.
The amount of technology.
Yes, technology or the amount spent on to buy these two factors of production. If it increased, in this case, we can buy it by a rightward shifting of the ISO cost line, because the ISO cost line illustrates the ability for the firm or for the business to buy different factors of production. But let's come back to our exercise. If the price or suppose that the total cost or the amount that the firm has to be spent on these two factors of production increased to $2,000. What would happen to the ISO cost line? Excellent. Let's come back and do the analysis. So, question is derive the new ISO coastline and the new ISO coastline formula. This is the origin formula, and let's go to the new data or new information. The new information is that the total cost increased to $2,000 and the price of L that remains constant to at 10, and the price of machines remains constant to $20. So let's derive the new budget, the new ISO coastline, and derive the formula. So in this case, Q, L, and U equals how much? The new total cost over the price of L. 2,000 over 10 equals 200. QM and U equals the new total cost over PM, $2,000 over 20 equals 100. So there is a double increasing in the quantity of labor and machines that the firm can purchase. So this is the origin QM, QL. This is the origin ISO coastline. How much was QM? 150. Now we have a rightward shifting of 50 و100. Okay. This is 50 and 100. The new is 100 QM and 200 QL. So let's derive the new ISO coastline formula. Or sorry, the ISO coastline. In this case, as you see, that the number of labor has increased, that when the total cost increased, or the amount available for the firm to buy, and the quantum of machines has increased as well. So there is a double, as you see. In the previous case, the quantum machines that the firm was able to buy was 50, and for machines, for labor is 100. Now there is a double increasing. So in this case, the new QM is how much? 100, and the quantity of labor is 50, 200. In this case, there is a rightward shifting of the ISO coastline. يعطيكم